So here we're looking at some graphs, and we're going to determine if a function is continuous, differentiable, or neither or both. Differentiable is a new vocabulary word, and it means has a derivative. And we've sort of already talked about how you can tell if things have a derivative, but I just want to relate it to being continuous as well. So let's look at A. I know that at 3, it's not continuous. And I know that because the limit as x approaches 3 does not exist. Well, for it to be differentiable, it has to be continuous. There's no way I can draw a tangent line at 3, so there's no way it can be differentiable at 3. If I can't draw a tangent line, I can't find the derivative. So it's not differentiable. Because it's not continuous, that makes it not differentiable. B is not continuous at 1 because the limit as x approaches 1 does not equal f of 1. And you could just say f of 1 doesn't exist. That would also be another reason it's not continuous. Again, because it's not continuous, it can't be differentiable. So if you can prove it's not continuous, then you know for sure it's not differentiable. Now C is continuous at x equals 0 because the limit as x approaches 0 equals f of 0. Now whether it's differentiable or not, the way that you have to tell if it's continuous, then being differentiable means that the slope is the same on both sides. So as I draw tangent lines and I think about the slope, on the left side it looks like I'm approaching 0. On the right side, as I approach 0, it looks like those tangent lines are also approaching 0. So it is differentiable because the slopes approach, I spelled that wrong, 0. If you didn't know what the slopes were approaching, but they were approaching the same thing, you could say that they are approaching the same value. Alright, D is continuous because the limit as x approaches 0 equals f of 0. It's connected. But it's not differentiable because the slopes are not the same. Slopes approach different values. Because like if there's a line there that's approaching some negative number. On this side it looks like it's approaching 0. That's coming to a sharp point. And so it's not differentiable because the slopes are approaching different values. If I ask you, is the function continuous or differentiable, and why, you have to tell me the reason it's continuous or not, and then the reason it's differentiable or not. Okay, I'm going to erase all that so you can see the next 4 more easily. E. E is not continuous at x equals 2 because the limit as x approaches 2 does not exist. If it's not continuous, it's not differentiable, and that's your reason. F is continuous at x equals 0 because the limit as x approaches 0 equals f of 0. Those pieces are connected. But it's not differentiable because the slopes are approaching different values. You can't just say it's a sharp point. Sharp point is the reason why, but the calculus way to say it is to talk about the slopes. Same thing as continuous. You can't just say, oh, it's all connected, so that makes it continuous. you have to talk about the limit. Same thing with differentiable. You got to talk about the slopes. Again, I'm going to erase that so you can see G and E better. G is continuous at x equals 2 because the limit as x approaches 2 equals f of 2. Things are connected. But it's not differentiable because the slopes are approaching different values. We have a positive slope there, and on this side it's approaching 0. It's a sharp point. So not differentiable, slopes approaching different values. Okay, and lastly, at h, it is continuous at x equals -1 because f of -1 equals the limit as x approaches -1. I said that backwards, but it's okay. And here's the very, very tricky thing. We haven't talked much about it, but on this side the slope is approaching a really big number. On this side it's approaching a really big number. Well, those really big numbers are approaching a vertical line. And because they're approaching a vertical line, because the tangent line is vertical, that means it's not differentiable because the slope of a vertical line is undefined. So it's not differentiable since the tangent line has an undefined slope. So there's several reasons a function would not be differentiable. First, it's not differentiable if it's not continuous, like a and b and e. Second, it would be not differentiable if it has a sharp point, d, f, and g. Third, it's not differentiable if we're approaching a tangent line where the slope is undefined. So there's 3 more problems I want to look at, and it's if you're not looking at a graph and trying to determine if a function is continuous or differentiable. So this is an example of a piecewise function, and if I'm trying to figure out if it's continuous or differentiable, I start with being continuous. So I plug in a 0, and if I plug in a 0 on top, I get a -1, plug in 0 on the bottom, it's a 5. That tells me it's not continuous because the limit as x approaches 0 doesn't exist. Those two things have to be the same for the limit to exist. Since the limit doesn't exist, it's not continuous. Because it's not continuous, it's not differentiable, and I don't have to go any further. But you always need to check continuity first. The slopes on both of these were 4, so they would have been approaching the same value, but it's not continuous, so it doesn't work. Number 2. So you start off by checking to see if it's continuous. You plug in a 1 on top, plug in a 1 on bottom. Those are the same, so it is continuous because the limit as x approaches 1 equals -3, and that also equals f of 1, because I can plug in a 1 into there since that's where the equals is. To figure out if it's differentiable, I have to check the slopes on top and the bottom. Now, I'm not going to take the time to work out the slopes exactly, but I will tell you that if you did the f of x plus h formula and work it all out till you get to the end and plug your 0 in for h, on this part of it, you would get that the derivative was 4x minus 5. On the bottom, I don't have to work that one out since that's a line. I know that the derivative is -1. So what I'm trying to figure out is if those two derivatives are the same. I want to know at 1, if I plug in 1, do I get the same derivative? So f prime of 1 on this side is negative 1, and I already know this one's negative 1. So on both sides, the derivatives are approaching the same value, so it's differentiable because f prime of 1 is negative 1 on both sides. If I would have got some other answer from one of those, then it would be not differentiable even though it was continuous. That would have meant there was a sharp point. Alright, last one. Plug in the 1 to make sure it's continuous. So 1 on the top would be 2 times 1 minus 1, which is 1. Plug in the 1 there, you get 1. It is continuous because f of 1 equals the limit as x approaches 1. To figure out if it's differentiable, I need to find the slopes. I know the slope on the top is 2 because that's a line. On the bottom, that's another one I would have to work out with the limit as x approaches h and do all of that stuff. Again, just for the sake of time, I don't think I have to do that for you. But you get 1/2 or 1 over 2 and then square root of x. So plug in the 1. Alright, so if I plug in a 1, then at 2 the derivative, at 1 the derivative would be 2. Plug in a 1, the derivative here would be 1/2. These two are not the same, so it's not differentiable. Slopes are not equal.